Thanks for the invite. This is a talk that I gave a week ago, for almost exactly the same slides, a week ago at the RIPE conference in Budapest. These slides I've been taking to different places to talk about an event that we're doing in DNSSec at ICANN. And it's tuned mostly for network operators, ISPs in general, but I'm going to use the same slides. It's not that specific to ISPs, but I'll try to tailor what I say to a different crowd. Now, a question here, how many people here work at an ISP? Okay. How many do system administration as a main concern? Okay, that's kind of what I was expecting when I was studying. So the history behind DNSSec, I go back 20-something years with it. My first talk about DNSSec was in front of a system administrator guild audience. It's been forgotten to history by now. That was actually the very first time. And since then, we've gone into network-specific areas. So the purpose of this talk is we're doing something. We're rolling the key KSK. That's the short name for what I'm doing. And I'm going to talk about what we're doing with this thing, with this process, and give some resources for those who might be involved, who are impacted by what's happening. I like to use the word impact, not affected. How many here know anything about DNSSec? Okay, I'm in Holland, I expect that. And I don't mean it as a hollow joke. I've been in Holland, I forget, maybe 15 times in the last 17 years to talk about DNSSec. NNet Labs has Unbound and NSD. There's also the Power DNS folks, and many researchers come out. So this is one of the areas that has, one of the regions that has really taken on to this technology. So I'm not surprised. So how many here don't know what DNSSec is at all, and are not afraid to admit it? Okay. So just to give you a little bit of background, DNSSec is designed to add security to DNS. The history is that the DNS protocol, it's not exactly client-server, it's clients that access caches. Caches go to servers. This sounds like it's a little bit loud, isn't it? I hear it. And so we were asked 20-something years ago to come up with a way of getting a way to securely send information from the server to the stuff out there. It wasn't meant to be a way to secure the internet, just a way to secure what flows through the DNS. And the DNS itself, it's a very clunky protocol. It's like a caveman protocol written a long time ago. There are many reasons why a protocol should not be built the way the DNS is. We've learned many things since it came out, but it's infrastructure, it's there. DNSSec came along and we tried to fix that. Well, I'm sorry, we didn't fix that. We had to deal with it. So when DNSSec is clumsy and broken and all this, it's actually underlying the DNS. We did want to change the DNS when we made it more secure. So DNSSec basically just adds digital signatures to the data as it flows through the DNS. So when the authoritative side wants to say this is the answer, they sign it, and they pass it through the caches, and it goes to the end user, who can then, through a series of cryptographic checks, have some confidence that that was what was sent across from the start. Now, earlier there was talk about DNSSec is broken and not secure. There are many things that can go wrong in this process. They're above the DNS. So you can put the wrong information in, the wrong information comes out. But for all this to work, though, the reason why I'm here is that this DNS, which is a very hard system, we have a key that sits on top of all the keys in the DNS. And the top key is called the root zone's key signing key, the root key is KSK. And schematically, I show up here where the key up on top, that one signs another key, which signs another key, and so on, and lets you take the digital signature you get with that data and then validate it back up to this root. The root is what you trust. This is all about trust that's set by the users out there in the system that we're running. But what we're doing today is, what we're doing now in this year, is ICANN, which is operating the KSK, and I'll get into what that means, is changing. And that's pretty much what we're doing. There's a couple reasons why this is a really big event in the world. It's very interesting that we're doing this. For one thing, we had many years with no security at all. There was no keys at all. We put one in 2010. When you go from nothing to one, it's not necessarily it doesn't impact a lot. It might break a few things, but people don't notice it generally. This is a whole new thing. And so now we were told after 5 years we should roll it again, change the key again. And we're doing this because of maintenance. We don't have to do this. There's no emergency out there, nothing broken. We're just changing the key from the old value to the new one. We're finding that going from having one to having a different one is harder than going from having nothing to going to one. For one thing, in DNSSec is, I don't know who's actually relying on the key. There's no roster. I can't check down there. I can look at network traffic and figure out maybe you're doing it, maybe you're doing it, maybe you're not doing it, but we really don't know. We've tried looking at that. It's not very reliable. So the hardest part here is just simply talking about this and letting people know that we're changing the key. So that's what we're going through right now. Now, the organization I work for tries to, we want to make sure people don't get panicked or scared or run away from DNSSec. The fact is, operators who are involved with DNSSec and people who want to take advantage of it, you may have some work to do in preparing for this, but maybe not a lot. Hopefully not a lot. So where we are in the process here is the first line is we have the new key that's been made. We created the new key in one data facility. We have 2 data facilities. It's in that data facility. It's also been transported to the second data facility. And those are the first 2 dates. So October last year, we made the new key. A quarter of a year later, we put the key into the other side. Why it's taking so long is because we're not in a hurry. Simple. We have a quarterly way of maintaining the key. We're just slipping into those dates. No extra expense. We're not putting more money into this thing. And we're not in a hurry. I've been asked that question a few times. We could go faster, but we're not in a hurry. It's not. So, plus, now in the out-of-band publication phase, we're trying to make sure people understand what we're doing, make sure things are ready, giving out resources, making sure you have systems ready to go. July 11th, the key will appear in the DNS. Hopefully, that will not be very interesting as an operator. It'll appear there. It may make the packet bigger, but other than that, we don't expect anything really disruptive at that point. Except it's a change. Change is bad. Change is risky. October 11th is a date where we start signing with the key. And from a DNS point of view, that's a big day because if you only know the old key, you will not see any more data come out of DNS. It will fail all day long. Nothing comes out. So October 11th, that's kind of the drop-dead date to make sure you follow along this process. If you're doing DNSSec validation, I should point that out the whole time, too. If you're not doing DNSSec validation, this is not going to be seen anywhere. Then 2018, we start cleaning up. We get rid of the old stuff and we run. There is one other date that gets mentioned sometimes, and you see in some of the tweets out there. September 19th. It's about 20 days before October 11th. At that point, the key set, the answer you're going to get, the important answer, I don't want to say key answer, the important answer with the keys gets big relative to V6. And that, if you do V6 traffic analysis, there may be something interesting to look at there. I'll talk about that too. So, for those who are looking for the new key, this is what it looks like. You can actually trust this. You can trust anything on the screen. This is yet another way to trust the key when you actually see it through a better format. The new key tag is up there, 20326. The current one is like 19036, I believe. The DS record, for those of you who know what the DS record is, that's what it would look like. Of course, if it actually existed, but that's what you can figure it looks like Unbound or some of the other tools out there. And the DNS key record out there will look like this. Right now you can't see it anymore, but this is what will appear alongside the current key starting on July 11th and going on. Now the reason for the 2 kinds of records I put out there is because the tool you use determines which of those forms you want. It's up to you what you use, and they use one or the other. We've been talking with a lot of tool makers, and I'll try to get into that during the talk too, to make it more flexible to manage the keys. This is an area that no one's really written much code in, and we're trying to make sure everything is very smooth going out. Like I said, today, everything's nice, sunny day scenario. It's smooth sailing out there. If you're using DNSSec today, validation's working for you today. We're just making a change because we like to. Because we should. We should do this update. It's important, I mentioned this only because the opposite is we're in trouble, we gotta do everything from start again. We're not doing that. But because things are smooth, the easiest way for someone to follow along in this, depending on your trust system, is to use this thing called automated updates of DNSSec trust anchors. RC5011 is the buzzword for that. And that basically says, and I think I have it on the slide, so it basically says this: I use the current key to sign the new key. And I put it out there for 30 days. And if in those 30 days you don't hear any complaints from anybody that the key is wrong, you accept that key as a trust anchor. And software will actually automatically add that to the trust anchor set, and begin running like it does today with only one key, and I have two keys, so we're a new key. This has been out there for a while. Some people play with it. It's not been played with a lot. It's not been used a lot because most people nowadays roll everything up to the root zone anyway. We've never changed before. So on the calendar, this is kind of what it looks like. July 11th is when the new key appears in the DNS. That's when you start the RC 5011 30-day add hold timer if you're doing this according to what we anticipate people will do. I should point out too, I want to stress that I'm not saying you have to do it this way. This is just one way to get in the key, but one that's probably the simplest for you to follow along if you let your machine self-configure. So 31 days or so later, on August 11th, you should see this key marked as trusted by your software. Provided your software is new enough to let you do this. One thing that's been changing most recently in Unbound and especially in Bind is those two manufacturers have been working on their code to make sure it has proper documentation, proper logging, and proper debug output to watch this process. So it's a good reason to have the later and later versions of it. You then have, from August 11th, you have 2 months to panic. 2 months to prepare if things aren't going well. Because on October 11th is when it matters. But you have some time to watch it come in naturally, and you have 2 months to go around and do this. I should add, too, that today, if you trusted my slides, you can go back home today and type the key in, and you'd be fine from our point of view. We have the key, it's ready to go, we're not using it yet, but if you want to trust it right now, you can. There's nothing stopping you from doing this. It's your key. It's actually your protection. They're for your protection. So don't panic if your things don't go the first time. We have a test bed. I run my code as an outsider to it. I didn't run the test bed. I didn't write the test bed. I've been using it. Worked for me on Unbound, worked for me on Bind. Other people say it doesn't work for them. So it's up to you to look at your environment. You know better what you have. One of the common causes of failure, one of the causes of failure I hear from many people is I can't write to my disk. Well, if that's the case, you have something to fix, but that will cause a problem with this process, and trust Anchor Manager. Why are we recommending this? Why are we going to it? Well, because from a security person's point of view, it's the cleanest one out there. You don't trust anything else out there. If I grab the key from the website, I'm trusting web certificates, I'm trusting the internet, I'm trusting a bunch of things. If I grab the key from my friend, I'm trusting my friend. If I'm grabbing the key from the software distribution, it's a software distribution out there. They're all fine and they have different limitations, but through 5011, you only have to trust the old key and nothing else is really being touched. That's what a cryptographer likes about this process. Having once operated many systems, I sometimes don't think cryptographers are the smartest people in the world, honestly. Sometimes when you're an operator, you want to control things a bit more than having your systems configure themselves out there, but maybe use this as one of the canaries in your system. You have a 5011 following server. When it shows you the key, you also combine that with other ways of doing trust, and you configure your systems through whatever else management system you have out there. So if you decide to go the automatic route, you take your name server, you say listen to 5011, it's done. You just have to let it run and it should do things. As an operator, I never like it when something should do something. I want to make sure I know what's happening, so I'm nervous of that one. But if you decide to do it on your own, if you want to bootstrap the trust, if you want to build trust by looking at things at your own desk, one of the operators at one of the major ISPs in the US told me, I want it 3 ways independent of each other. And then do all 3 agree? I go forward with that. And I like that. I like that philosophy. You might do other ones. But we've been doing it within ICANN. I am the operator of the PTI now, Public Transport Identifiers, by the way. They had to change their name. We're sending you the key first through 5011. The second way, we have the key on a website out there with some detached signatures that you can grab and pull down. That's the second way we can put it out there. We have by other means. The DNS is the other means on here. On other means are, for example, we've been working with the software distributors to make sure they have a new key. So if you pick up Bind, since the day we made the key production ready, they put it immediately in their next release. So 9.11, whatever. In fact, any updates of Bind today going out will have the latest key configured in there. I believe Unbound has. I haven't checked, but I believe that they've done, and they certainly know about this. I know them well. And a lot of the other ones who are shipping the key actually are starting to embed this already. Now, also, the slides are out there. Slides, it's kind of a joke, but the slides are out there. We have t-shirts, we have stickers. We're not giving them out, but we have them too. And finally, you can get it from your friend, and if the friend gives you the same copy you see in it, it's It's up to you. It's all up to you how you trust. So the call to action here is, this is a slide meant for a more general audience. If you're a user of this, you make sure your suppliers know about it. That's what this slide is saying. And if you're a supplier of the services, keep reading. And I'm going to keep going because I have a lot more time to speak. So as an operator, and if you're a good operator, you probably don't need these slides. But first of all, find out whether or not you're doing DNSSec. I can imagine sometimes when someone may have been energized in 2011 to turn on DNSSec validation at their place, and then they leave. And it's been running for all this time without anyone noticing it because it actually just runs. It actually does just run on the commercial server side. Make sure, see what you have, just so you're not surprised at it one day. Be aware how you develop trust. Have an idea, do I trust one thing coming to me? Do I let my system self-configure out there? Do I let the edges of self-configure? Maybe, maybe not. But knowing what the process is going to be. How am I going to roll this out? How do I roll a configuration file to my system as opposed to production code? Or just code in general. Test and verify. I've always been a believer on having an automated way of finding out what your systems are doing. Inspecting the configuration files. Many people will update software repeatedly and just let the config file sit. And when I get to bind, I'll explain why there's a concern about that. And if you're doing it or planning, make sure you're aware, or be aware of these talks. Be aware of these dates we have out there and make sure people know about it. And also, if other folks in your area are doing this, make sure they're aware of this too, please. This is actually where I might get some help from the crowd here. These are the 8 code bases that we know DNSSec is done in. 5011 is not in all of them. PowerDNS does not do it. But most of these are doing 5011, doing this software out there. I see these are the people I talk to. I see the software developers. And what I'm not as familiar with is when you go up the stack, when they get packaged in OSs. I do know people from Debian and a few other distributions out there that are aware of this. Systemd folks also aware of this. When they ship code, operating systems out there with this key in the code base, that needs to be updated too. It's not just, see, I'm a DNS person. See, this is my view of the world. I'm a little less cloudy when it gets up into how it's packaged and delivered systems. And so that's where, if there are more information to make sure that this distribution has it, please let me know. Like I said, we're aware of a few of them. Like I said, Ubuntu and Debian folks have been involved with this. Beyond that, I'm not so sure who we've talked to.
Yeah. Yes. You said PowerDNS doesn't do 5011?
I believe they do not.
Who runs PowerDNS for those?
I'm sure because Bert Hubert last week was making comments to me that they don't do 5011. So they do DNSSec. Okay, so what's special about Bind? Bind is dear to our hearts, many of our hearts. They've been around forever. They were inside the house as we built DNSSec. The penalty they pay is they've implemented very old versions of DNSSec. Now, code has been updated. They've fixed things over time. We've discovered that some people still have configurations for Bind that predate the key that's being used. So in Bind, there's a specific option called, I have it down below, trusted keys. Trusted keys were the old way to put a key in the DNS in Bind's configuration that stayed there statically, never changed. In February 2010, the version of Bind came out with something called managed keys. Managed keys was you put a key in there, and then if it ever gets 5011 out, it gets updated. Managed keys is the dynamic way of managing keys. So if you have a Bind configuration from way back when, which would still work today, with the trusted key set to the current key, you got to look at your config files. And this is the funny thing, because most of us didn't think about updating this, as we kept updating from 9.9.2, 9.3, to 9.11. We never looked back at some of these old config files. And having been so old that I saw Bind 4 and Bind 8 config files, I still see people using Bind 8 config files with comments around. They put the Bind 9 configurations in there. So Bind is unique and special in that way. Microsoft has, we asked for folks for pointers to documentation. They have two things here, two documents, which even though they seem dated now, but they actually apparently are up to date to the Windows version that's running DNSSec. It talks about the trust anchor management in there too. Unbound has a presentation I've been pulling out. I'm not sure that there's anything more formal from them yet. PowerDNS has information on trust anchor management there. Again, they have to do it statically in that place, that's code out there. The not resolver. Does anyone use not resolver? Does anyone know what not resolver is? Okay. Not Resolver is a product of the Czech Republic CCTLD. And it's a research project, and they've been very active in this, and it's got a lot of different features, but I'm not sure it's got any commercial use anywhere, to be honest. I may not even be 1.0 yet, so I don't know. Authoritative server is actually used up and down the internet, but not the developers. The DNSSec also has some things about the trust anchor management built into it. It's very interesting. The change log they mentions it. So when things go bad, how bad can they go? How will they go bad? There were two things that we anticipate as issues. This is another weird thing about this project. We can't test it. It's impossible to test this. We tried hard. We were preparing for this, but we can't test what happens because we can only if we test something, it's going to go bad. It's going to go bad for real too. That's the testing part. So there are two things we're concerned about. We looked at fragmentation of packets. What's going to happen is we're going to put out some fairly large responses for the root key set at some point. And that has scared some of the IPv6 folks out there, and I'll get more into that in a slide. There's also a chance that you don't follow this update and you end up with the wrong keys, the wrong trust anchors, and these are the two scenarios out there. One of them you'll see a lot more fragments, if it's the first fragment, the first error. The second one is going to be a lot of retries in the DNS. The DNS just won't work. So what's the scary thing about IPv6 and the DNS? And to be honest, I hear more and more scary things coming out. The more we research this, the more we get like, oh my God, one more thing might go. So I think Happy Eyeballs is helping us here. In v6, fragments are done only at the source and reassembled at the destination and not in the middle. And the idea is that if something halfway through the network says, I can't handle that packet, it sends back an error message back upstream saying, the packet was too big, send something smaller. It sounds kind of great in theory. The problem with DNS is DNS servers don't remember what they sent. It's stateless, kind of stateless. I send out something to somebody, I get back it was too big. What do? I can do nothing except remember next time maybe I won't send such a big thing to them. This has been a concern. Also, the threshold here, we're not really sure what the threshold really is. 1280s is numbers are afraid of. If it goes above 1280 bytes that is in a return, it might get fragmented, it might not get fragmented mostly because v6 tunneling is where it comes from. So to look at what this means to us, this is a fancy color-coded chart showing how big our responses are going to be through the process. The 1280 byte limit goes down and time is going down. And at some point, in September 19th is a date that we go to a very large packet for the first time. Very large being above 1280. It's a somewhat arbitrary number. At that point, some people who worry about fragments may see some issues, and so we're concerned about that. Again, we go about a couple weeks later, we hit that again, and then we go a little bit bigger in January 11th when we do some of the revocation and take things out. So these are times when anyone, even if you're not doing DNSSec, you might see something on the network. If you are not running DNSSec and you're running a network, you might see fragments because it's going to somebody else down the line. So this is where the concern comes from. So fortunately, we have been able to do some experimentation in this area, and it turns out that a lot of TLDs have really big sets of keys out there. So we started scanning them every now and then to see how many of them actually come in, how well can we grab large key sets from the TLDs out there. Turns out we can actually get through to them. It actually works, but it works better if TCP is available. So, TCP isn't necessarily the answer to everything, but bear with me with this. I recommend this. Make sure that you're running TCP around your recursive service. Recursive service is generally a UDP, and many firewalls can free to let that only go through UDP. Make sure TCP is available. Make sure you can do that. You should anyway. It's not just for the key rollover. It's really part of the protocol. The second thing we can do here is to see what your limit of size is. There are two test beds out there that you can use. VeriSign Labs has a way to test how big a packet you can receive in DNS. And they've updated it again for this test. I talked to them recently about it. I told them I was going to re-advertise this fairly old service. Also, DNSOR, which is the DNS Operations and Research Center, has some resources for that also. But this is a permanent fix thing. This should be working well. Forget the key roll. This should be working well anyway. So I think it's a good thing to recommend. To recover, first thing, stop the tickets. We had some debate about this. It's okay to turn DNSSec off if it's really bugging you, because if people complain about it, let the complaint stop, fix this. It is like seatbelts in a car. You really want to have them on, but there are times when they just don't, it may hold you back. But I was also urged just to make sure, please turn it back on afterwards. For your protection, frankly. Debug this, find out what was the cause. Was it the fragmentation? Was it the failure to follow the key rollover? Was it anything else, bugs, anything like that? We like to learn lessons about things when things go bad. So it's very important to do that. And then also test. This is a thing that the operators know this pretty well. Before you go back to live production, you test your fixes before it goes out there. So towards the end of all of this, ICANN has been trying to provide as much as we can to help you get through this rollover process. First, one thing we provided is a Python script, which basically can pull the keys in off the website in a few other places and do checks. This script can either be used to help you understand how we intend trust to be seen. It can be used to actually just pull the keys off of the sites, and it writes files that can be used anywhere. You can use it any way you want for this. There's also a test bed, and again, I guess I'll go through this again after this. And we have documentation. The Python script, which I was just talking about, it's a newer Python. You run it with the run command, it's right there. It'll show you, here are the trust anchors. If you run it today, you'll see it list both the 2010 and 2017 key, because they're both out there right now. It'll write out the DNS key records, and you can use that for configurations whenever you want to. And if you're someone who likes to have many different ways, this is one way of getting the key. I hope the slides will be available online.
The video will be online in 5 minutes after the talk.
Right. Also, not to plug it, but RIPE has these, if you're looking for the URLs, RIPE would actually have this talk there, so you need to find that there too. So for the automatic updates testbed, this is a testbed designed for people who are operating servers out there. Now, it's just, the reason why we're careful about that is there have been some 5011 testbeds already floating around. They require people to change the code's timing to do this, because 5011 takes about 6 weeks to run. It takes 1 month to do the hold down time. Your revocation takes some time. It takes about 6 weeks for this to run, so it's a long-term process. It's not very exciting to watch. But for software developers who want something faster, they were speeding up timers, they have the tricks and bind and unbound and so on. But this testbed is built for the situation where you sign up for it, we give you instructions, you configure a server, and you let it run, you can watch it, see what it does over time. You'll get email that says, this is what you should do for bind and unbound. I think there's only two that we have documentation for, but it does anyone out there, whatever you want to run will come. And every week we do the test bed again. So whenever you go to the test bed and say, I want to join, there will be a test starting that week. So every Sunday, I think, is we start another round of this. So if you go to the URL on the bottom, you'll come to a website that looks kind of like this. The top of it is on top. You scroll down at the bottom, it says click here, and it will ask, you will be subscribed to a mailing list for this test bed, and then you can follow along. You should have everything you need in the instructions to follow all this way from. The new key will appear on the Monday, I believe, after you sign up, and then 30 days later it will become trusted, hopefully, and then after that you'll see notices saying you should see this now, you should see this now, and then they also revoke it at the end before you can shut this back down. And then the last email says we're done with the test. We've done a few of them already. Every week it happens out there. This is really designed. I want to stress too that this is testing a zone that's way down in the tree. It's one of the zones we have way down under ICANN.org. So you can put this on a live server if you really want to chance it. Frankly, testing on live production is kind of iffy, but this would fit on a live production server, and you're looking at a test zone way down in the tree. So, and then before I close, we have some documentation available. ICANN.org has if you come to our main website, there's a drop-down quick links, or not, it's a list of links down there. KSK Rollover is mentioned in there. From that page, you'll go to a page which will give you a whole lot of information. We keep it up to date. Everything that, probably this presentation should actually be on there too. So again, if you need to go find the slides some other way, it should be at that website, or that URL. Excuse me. And with that, I've got my normal closing slide here, and I'm open for questions. Sorry.
Will the new KSK be signed by the original key signing key or by the zone signing key and clouds appearing?
It's signed by the original key signing key. The way the DNSSec works is I have, at the very top, I have the SOA record, right? That's signed by the zone signing key by the one who operates the zone signing key. Then we have the DNS key records, and they're always signed only by the KSK. So if you go today if you do a look at the root zone's records, you'll see the SOA is signed by the ZSK, the NSSec is signed by the ZSK, whatever else is up there is signed by the ZSK, the NSSec record, and so on. But the DNS key set is always signed by the KSK. And one thing I'll add too at the root zone, if you're familiar with how we operate, we have the KSK and the ZSK are managed by different companies, different entities. The key signing key is operated by ICANN. The ZSK, the zone signing key, is operated by VeriSign, and they're under contract to us to do that. So we actually have that separated too.
Any more questions?
Yeah, the ad hold time you said is 30 days. What's that based on?
An IETF standard. To be honest, I don't know why 30 days. RFC 5011 was a document produced through the IETF quite a long time ago now, and I'd have to go back and try to research that. The whole idea though was that 30 days are meant. The way the protocol reads basically is that at some point I'm going to tell you, here's the new key signed by the old key. I'm going to keep advertising that to you, right? Now, what's to stop someone else from breaking the old key and adding a key to that? We don't know. So what we did is said, well, for 30 days, you should see from me the new key signed by the old key, and the old key is also in there too. But if someone else has managed to break the old key, the legitimate owner would say, wait a minute, I'm going to revoke the whole thing. I can stop it. So the 30 days lets me say, stop the presses, don't go to it. That's what the 30 days is for.
So all the resolvers have that coded in there with these 30 days.
Yes,
we're going to find out if it works. No.
Yeah. I can tell you, I know Bind, Unbound, and many of the other ones have had it for a long time. Power DNS is the only one that I heard it does not do it. We haven't tested all of them ourselves. But I would say that the software has actually been exercised and tested in many places. So we don't think that's the problem. We don't.
That bit has been tested.
Right. We're confident in that part. Stand bring it back here. I think the closer I get to you, the more the speakers get my mic. Other questions?
Yeah. Now it's on. How does the recovery look like when you enlarge the KSK packets up until 1400 somehow bytes, and a lot of IPv6 connections start to fill? What's going to be the path to recovery?
Well, from what I've seen of with the TLD experiment I did, there was only one TLD I couldn't get the key from over TCP. But there's a lot of caveats. See, every time you try to test this, I can't test the pure environment I'm going to see. One thing that we notice is that most of the resolver code out there, the bind, unbound, and the fully functional, they're very aggressive. They're really good at finding things.
Yeah.
Number one. Number two is that in our instance, there's a V4 for every server that does V6, and for better or worse, most of the traffic today, the happy eyeballs does V4, V6 prefers V6, but that fails to go to V4. So we think on the surface you may not see an effect, but we're watching for below the surface. We're concerned about efficiency, and if you're at that level, there are some things to watch out for, and it's hard to say because I've tested from many different locations, and the locations all have different characteristics. Like at my house, I use my house as the worst possible case. The V4 network is flawless, but the V6 has issues, but it always works.
Yeah, I can imagine that when you use IPv6 over in a tunnel over PPOE,
Yeah.
for example, with bad path NTU discovery, that will broke eventually.
Yeah, see, what happens here is how many people are going to run DNS servers in a house like mine that has the worst possible? This is going back and forth in all of this. You know, like we know that there's a Google public DNS has most of the DNS traffic out there, right? They're not going to have a problem. You know, they're all over this. Some of the larger ISPs that are really invested in DNSSec, they come to conferences, they know all about this. So we're balancing with all of this out to who do we think are the group that we're probably going to miss the most? You know, that's the other thing too, is that we're talking to so many people. Hopefully people are aware of this, but we still don't know this. The people we don't know about are the problem. And we can't do anything about it because we don't know about them. It's back and forth. So we're trying to anticipate where in the sphere we're going to see problems in that day. And also with V6, it's funny, Jeff Houston keeps going more and more issues about this happening.
Yeah, when we first talked about this, I was like, well, why don't you just add one top-level domain that's only signed by the new key, so you have a test case you can test. But unfortunately, you're not allowed to mess with the root zone like that.
That's the other thing. The rule, because like I said, we have so much. The value of trust in this is all about what people think of it. We don't have the engineering freedom to do just a test. You'd be surprised. We've been in offices and we have everybody who knows DNS like, what can we do? There's nothing. We're not. We could do some testing out there, but then we're breaking the chain of custody, and that will lose the trust. So that's why we're stuck.
I find it kind of funny that it's called a trust anchor, but at the same time it's being moved. So if you compare with a ship that is anchor to fix the position, then you lift the anchor and then the ship moves a bit and then put it down again. This way, in client implementations, DNS trust will be like blockchain. Like we first trusted this KSK 2010, and now it's 2017, and then it's 2000 whatever. And you have to trust each and every one of these keys, unless you manually said, "Oh, okay, I'll only trust the last key."
So much time I have left. Okay, so I can answer your questions. I actually was one of the people who wrote the first code on this way back 25 years ago. And number one thing about trust anchor, the term trust anchor is being misused in our literature, honestly. Trust anchor meant on your end of the connection, where do you anchor the trust in this whole chain? On my end, I don't have trust anchors. I have secure entry points. Yeah, the terminology, I offer you a key. Here's the key I want you to believe. It's up to you to decide that. So the trust anchor terminology may be kind of funny because it meant to only say, as the receiver of the information, I'm anchoring my trust on this one point. And that's the trust anchor terminology. What I'm telling you here is, I'm changing the key I'm using, and you can trust if you want or not. That's the first thing. So there's a terminology mix-up that might be giving the wrong impression out there. And I've also, I've talked about this internally with the team I'm on, and the ship has sailed trying to clear that up. Because I know as a protocol designer what we meant, but it got written 10 years ago, and it's all wrong. So that's gone. The second thing you were talking about, this blockchain thing, and I guess the person who spoke on blockchain earlier isn't here. So I'm not going to really get in a debate about that. But one of the desires we had for research back in the 90s was to have this set up where I could have my anchor anywhere in the tree and try to go around. So if I trusted, www.example.com, I could then use that to trust example.com up to the root, and it's all up to me the whole way. The problem is that the DNS doesn't let me do that. Actually, I sat there at my desk, I tried to work on this, and the DNS points downward. All the DNS records, if you DS without DNS, DS points downwards. So trust can only come from the top down, and we're stuck, technically. So, I mean, the blockchain is admirable. If I could have distributed trust out there, it'd be great. I tried to do it, we couldn't with the protocol we're on. So,
Thanks.
it's actually one of my hot buttons, that particular issue is there. I really wish we didn't have to have one trust anchor, but the DNS protocol forces it on us.
Yeah, when I was looking at the previous presentations about you know, Docker and images and stuff like that. It was like, yeah, at some point somebody's gonna deploy an old Docker image that has the old key long after the rollover has completed, and that image will that box will be stuck.
Yes, yes, I know the old days of, one time I ran into cache poisoning somewhere, and my first thing was, where are the old backup tapes? And that wasn't the answer, but that was my original reactions going back to old data, you know, signing the zone with the old stuff. Yeah. Operations mishaps are going to be operations mishaps, whether you have security or not. DNSSec does make it, DNSSec actually makes your operations even more fickle because you need, what you might have gotten away with before, this will catch it. So, that's the nature of security.
Any more questions?
Thank you.